Sketch the graph of the given exponential functions. Write the equation for the graph's horizontal asymptote. Give the domain and range. Alright, so we're given f of x is equal to 2 times 1.5 to the x plus 15. Now, if we forget about the plus 15, we already know a lot about this. We know that it would be above the x-axis. Alright, so if we forget about the plus 15, this part tells us it's above the x-axis and increasing. And we could create a table of values for that. So if we have x versus 2 times 1.5 to the x, we'd have 0, 2. 1, 2 times 1.5 is 3. 2. 2 times 1.5 square is 4.5. Let's use, how about 6? 6 times 1.5 to the 6th is about 68. And if we had, say, negative 1, if x was negative 1, then we'd have 2 times 1.5 to the negative first, and so that would be 1.33, that would be 4/3. Let's just say 1.33 approximately. Okay, but that's not the function we were given. Our given function was f of x equals 2 times 1.5 to the x plus 15. So now, let's add 15 to each of these. And so that would give us 16.33, 17, 18, 19.5. If x was 6, that would be what? About 83. And so now if we plot those points, negative 1, 16.33. Negative 1, 16.33. Our scale is 25, so 16.33, that would be 12.5, so about here. 17, 18, 19.5. Alright, so there's a few points. Now, of course, later on, when x is 6, we're all the way up at 83. It would be about here. And so what happens here is we get a graph that does this. Instead of getting close to here, it's getting close to 15. Or instead of getting close to 0, it's getting closer and closer to 15. And so we get a graph that does roughly this. I skipped a few points in here, but the curve does roughly something like that. And so we get what's called a horizontal asymptote, and I'll draw that in purple here. We get a horizontal asymptote and it's certainly related to that value that's being added on. So we have a horizontal asymptote at y equals 15. The domain is still all real numbers. The range is no longer y is greater than 0. All right. Notice that the minimum value that this function gets very, very close to is 15. And so then the range is y is greater than 15. f of x is equal to negative 200 by 0.4 to the x, subtract 25. Now again, let's kind of forget about the negative 25 for a moment. All right, let's forget about that, and let's create a table for x versus negative 200 by 0.4 to the x. And so if we had 0, we'd have negative 200. We would have 1. Negative 200 times 0.4 is 80, if I'm not mistaken. Let me double check that. Negative 80. If x was 2, we would have negative 200 times 0.4 to the second power, negative 32. If x was 3, negative 200 times 0.4 to the third, negative 12.8. One more. If x was 4, negative 5.12. And so these values are getting closer to 0. And let's do one more. How about a negative 1? Negative 200 times 0.4 to the negative first power. So that's negative 500. Now, let's remember the minus 25. All right, so now let's subtract 25. So that's negative 525. Negative 225. Negative 105. Negative 57. Negative 39.8. I didn't subtract 25. Sorry about that. That should be a negative 37.8. Negative 5.12 minus 25. Negative 30.12. And so now let's plot those points. Negative 1, negative 525. 0, negative 225. 1, negative 105. 2, negative 57. 3, negative 37.5. 4, negative 30.12. And again, what happens here is if we put in a larger number, let's put in a larger number here for, how about, well, let's just use 6. What happens if x is 6? For the entire function, I'd have negative 200 by 0.4 to the 6th, and then I would subtract 25. And notice that that's pretty close to negative 25, negative 25.8. Approximately. So I have 6, negative 25.8. Alright, so notice if I draw a smooth curve, it's not approaching 0, but rather it's approaching that, what again we call a horizontal asymptote, and again it is at that value that's being added, well in this case subtracted, from the exponential part. And so we have a horizontal asymptote. And in fact, the horizontal asymptote is defined by y equals negative 25. And again, notice that that's related to that value that's being added, subtracted on the function. Domain is again all real numbers. Range, we would define the range in this case as y is less than negative 25. Notice how the asymptote and the range are related.